morning, Stingrays! Today is all about probability, ladies and gentlemen. Yeah, switch it up for you there. Yes, because I'll be going to reuse these videos in the future. I don't want to keep talking about it every day. So, today's lesson is all about probability. And what is probability? This is one of those lessons we're going to start with words, okay? So there are, I want to say 3 types of probability. We're going to focus on 2 right now. Yeah, I got marker all over myself. First is theoretical probability, and the second is experimental probability. We're going to do an example of both in this video, okay? So first, theoretical probability. If you can read that, hopefully you can read my slide. It is the likelihood that something should happen, okay? Should being the key word there. Should. Okay, the likelihood that something should happen. Now, we're going to transition over to experimental probability. You feel like experimental should kind of be this one, but it's not. Because once you've done your experiment, you know the actual facts, the actual numbers, the actual data. So experimental is the frequency that something does happen. So what we're going to do in today's little lesson, I'm actually going to take 2 dice. I'm going to take a black dice, and I'm going to take a red dice. And I'm going to roll them. And then we're going to get our little probability based on this chart right here. What's this chart right here? Relax, I'll tell you. Okay, relax, chill. So, if you look at your basic 6-sided die, there are 6 sides. Obviously, that's why it's called a 6-sided die. So, I have my black die and I have my red die here. Black, red. Okay, black and the red. Black is numbered 1 through 6. Red is numbered 1 through 6. We're going to be, in our little experiment, we're going to be talking about the likelihood that we will roll doubles. Okay, now you might think, if I were to roll a 6 on one die, that's 1 out of 6. Okay, very good. Now if I roll a 6 on the other die, that's 1 out of 6. So it should be 1 out of 6. It should be 6 times 6. It should be 1 out of 36. It's not. Because I'm not talking about rolling 2 6s. If I were talking about specifically only rolling double 6s, then you would be correct. It'd be 1 out of 6. But I could also roll a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, a 6 and a 6. So let's take it step by step here before I get too advanced. Okay, so 1 through 6. So the likelihood of rolling with 2 dice, the likelihood of rolling a double is 1, 2, 3, 4, 5, 6. 6 opportunities. I have 6 opportunities out of a total of 66 chances, 66 rolls, 66 spots. Why 66? Because it is 1 out of 6. 1 out of 6 times 1 out of 6. 1 out of 6 times 1 out of 6 is 136. That's the total amount of outcomes that are possible. That's the total amount of outcomes that are possible out of 2 dice. Are 36 possible outcomes. There are 36 possible outcomes when I roll 2 dice. Okay? So you have a 1 in 36 chance of getting the correct combination. Now, since I asked for doubles and doubles specifically, I can do a 1 and a 1, a 2 and a 2, and a 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. I said there were 6 possible combinations, so it becomes 6 out of 6. So it becomes 6 out of 6 out of 36 chances. There are 6 chances that I could hit a double out of 36 possible combinations. Simplify that. 6 goes into 6 1 time. 6 goes into 36 6 times. So the likelihood that I will hit a double, doubles, is 1 out of 6. Okay? So what I'm going to do, video's taking way too long already. What I'm going to do is, I'm literally going to take 2 dice, a red and a black, and I'm going to roll them. 1, 2, a 3, a 4, a 5, and a 6. And we're going to literally record the data right now. Okay? So I'm going to cut over to me over at the small group station, and we're going to roll some dice. Ready? Here comes roll number 1, and go. Boom! Started right off the bat with nice doubles. Very nice, very nice. So we got very lucky there. On our very first roll, we hit some doubles. We hit 6 and 6. Well, I could stop right there, but I do want to kind of continue and get all 6 rolls, and let's see if we can hit another set of doubles. Here comes roll number 2. And it does not. We get a 1 and a 2. A 1 and a 2. 1 and a 2. All right, on to roll number 3. Boop. Coming up short again. 5 and 3. Okay. Roll number 4.
At least in class.
3 and 2. Not very good. Not very good. And we have 2 more chances left. Once again, we hit our double on the first roll. Let's see if we can do it again with into 6. See if we can break the theoretical with a better experimental. Roll 5. 3 and a 2 again. 3 and a 2. Wait, no, 3 and a 2? Sorry. Roll 4 was a 3 and a 5. This one, it's a 3 and a 2. Last roll, can we hit 2 doubles? Can we break the theoretical probability with our experimental probability? Can we do better? Here we go. 1 out of 6. Boom. We do not. We finish with a 1 and a 4. Okay, so drop that one. Yep. So this is kind of a weird experiment because we did end up hitting it on our very first roll, and I didn't want to manipulate the data because I wrote roll at the top, and I couldn't change that. But yes, we hit it on our first roll, and then I wanted to see if we could change the theoretical probability to the experimental probability. So our theoretical probability was that 1 out of 6 rolls would be a double. The experimental probability matched that. It matched that exactly. 1 out of the 6 rolls. We could have kept going. Maybe we would have gotten 2 on the next set of 6. We're going to do something like this in class, and we'll see how many set of doubles we can get with 6 rolls. Yeah, I'm hoping to do some fun stuff with this. We're running out of time. We're short on class days. So we're going to do this. We're also going to do accounting of the kids in school. I'm going to try and do some small group stuff with this. We're going to see. We're going to try. All right. Oh, also, shout out to the 14 people being immortalized in extra math championshipness hood, iconic, whatever. Deuces.